Bismillah Rahman Rahim. Welcome to the first lecture of Chem 473. This course is about surface chemistry and solid state chemistry. So first I will teach you the surface chemistry, and today we will discuss about different terminology to be used in the surface chemistry. So what about the surface chemistry? It is actually the phenomena which is going to happen on the surface of any material. And here the material which we are going to discuss, and we are taking it as a solid surface. So the first process which is happening on the surface is called the absorption. So absorption is the penetration of the molecules of the liquid or the gas into the body of the solid. So it is the if there is the distribution or penetration of the molecules throughout the body, that process is called the adsorption. And the other one process is called the adsorption. So adsorption is actually the surface phenomena. That means it is the concentration of the molecules of the liquid, like in case is the dye or the molecule of the gas. The examples are the sulfur dioxide or ammonia on the surface of the solid, and the solid here in case is, let's suppose it is the charcoal. So this process is called the adsorption. Actually, this is the surface chemistry which we are going to discuss in this course, and the chemistry of the adsorption process. And it is the concentration of the molecules of the liquid or the gas on the surface of the solid. So further to clarify the concept, we will not be using the liquid, solid or the gas to define what is happening on the surface, but scientifically we will discuss with terminology, and the first one is called the adsorbate. So adsorbate is the substance that concentrates at the surface. It is called the adsorbate. That means what substance, that it is the liquid or the gases which are going to adsorb on the surface, that is called the adsorbate. And adsorbent is the material upon whose surface the adsorption process is going to take place. It is called the adsorbent. So in this case, it is the solid. So adsorbent will be the solid as we defined before, and the liquid or the gas will be the adsorbate. But this is not important. The solid will be the adsorbent, and liquid and gas will be the adsorbate. It is to remember which is going to adsorb on whose surface, and the surface is called the adsorbent, and the substance which is going to adsorb, it is called the adsorbate. And it is easy to remember the these two terminology, like adsorbent is similar to the other terminology you are using, like oxidizing agent, reducing agent. That means these are the main component who is going to be act in the surface phenomena. So adsorbent is the, that means it is the agent which is going to adsorb. That's why this is called the adsorbent, and the other material will be the adsorbate. So this is the simple example, the difference between the adsorbate and the adsorbent, and the adsorb and the absorbed. So let's suppose this is the surface, the empty one is the surface, and this is called the adsorbent. And the material which is going to be adsorbed, it is called the adsorbate. Let's suppose this is X, and X may be the liquid or the gas. So the first process is if it is adsorbed on the surface, and if X is adsorbed, this is called the adsorption process. If X mean liquid or the gas is absorbed, then the process is called the absorption process. So this is the penetration of the liquid and the gas throughout the body. That's why the material is absorbed and it is called the absorption process. This is happening just on the surface of the molecules of the adsorbent. That's why this is called the adsorption process. This is the mechanism how the adsorption is going to be taken place. The what is the here the platinum is the adsorbent, and the molecule of the hydrogen gas are acting as the adsorbate. And here the same, the surface is the same, platinum is the adsorbent and hydrogen atom are acting as the adsorbate. So the difference between these two, even the molecule can be adsorbed or the atom can be adsorbed on the surface of the adsorbent, and this is uh, the mechanism of the adsorption. So what is important over here? Here you can see this is the permanent bond because the platinum is the metal and there is the metallic bond between the platinum atoms, but between the hydrogen gas and the platinum, this is the temporary bonds. And similarly, between the hydrogen and the platinum, it is the temporary bond. So that means this is going to be happen during the adsorption process. So there are two type of the adsorption process. One is the physical adsorption, another one is the chemical adsorption. So if you have a look between these two images, the previous one and this one. So the first is what is the difference between this and this. The difference is here the adsorbent is the platinum, here the adsorbent is the nickel. So the similarity is nickel is the platinum. There is again the permanent bond between the platinum and the nickel as well. So metallic bonds are there. And of course, there is another similarity is adsorption process is going to happen on the surface of the adsorbent. Here the adsorbate is the hydrogen gas and here adsorbate is also a hydrogen gas. So now what is the actually this is the similar what we have discussed before in this example. Now what is the difference between these two? The physical absorption and the chemical absorption, and the the definition or the description is coming out of these pictures. So what is now the difference between these two? Here you are seeing these are the temporary bonds, but here hydrogen is attached to the nickel with the permanent bond. Temporary bonds mean there are the weak forces between the atoms of the nickel and the hydrogen molecules, and these weak forces may be the van der Waals forces, hydrogen bonds, ion dipole forces, dipole forces. There are many weak forces which are available, and you have discussed in the previous courses as well. And in the permanent bond, there may be the covalent bond, or it may be the ionic bond, or it may be the coordinate covalent bond. So this is the difference between the physical absorption and the chemical absorption. So in the physical absorption, there are a weak bonding between the adsorbate and adsorbent, but in chemical absorption, there is the permanent bonding or the strong bonding between the adsorbent and the adsorbate. So this is chemically adsorbed, this is physical absorption. So the absorption has the two process or the two types which are called the physical absorption or the chemical absorption, or in other names we can call it the physisorption, or here we can call it the chemisorption. This is the adsorption isotherm. And in the adsorption isothermy, that means isotherm, which is going to describe the adsorption process. Iso means same, therm means temperature at constant temperature. What is happening over here? This is the graph between the x and y axis. X is the, here is the pressure. It may be the concentration. If it the that means if this is the going to describe what is the type of the adsorbate, In case of the gas, it would be a pressure, and if the adsorbate is the liquid, it would be the concentration, and this is increasing on the x-axis. So on the y-axis, this is x is the again the concentration of the adsorbate, and m is what is the concentration of the adsorbent, the amount adsorbed in unit mass of the adsorbent. This is called the x over m. This is the ratio between adsorbate and the adsorbent. So what is happening over here? At the start, there are three stages. This is the stage 1, stage 2, and stage 3. This we call the initial. This is the central point, and third one is the horizontal point. So here you can see this is the sharp increase when the concentration of adsorbate adsorb on the surface of the adsorbent. And I'm going to explain with reason why this is happening, why this is sharp, and then it is little bit inclined, and then it become horizontal. So at the start, all pores or the surface of the adsorbent is empty. So all pores are empty. So there is the maximum capacity to hold the concentration of the adsorbate in the form of the gas or the liquids. So that's why there is the direct increase or sharp increase in the graph uh, with the as soon as the concentration of the adsorbate is increased, and then it becomes inclined. That means now it is going to decrease as compared to the initial stage. Why this is happening? Because now some of the pores of the adsorbent have occupied the concentration of the adsorbate. That's why it is going to be inclined, and then it become horizontal. That means now there is no increase or decrease in the concentration of the adsorbate on the surface of the adsorbent. Why? Because all pores of the adsorbent have been occupied with the concentration of the adsorbate, and the equilibrium has been achieved. So that's why this line becomes horizontal. So this is all about the adsorption process.